Hello friends, today we are discussing about the vector control method of induction motor. Induction motors are used in widely in industries. So we have to control the induction motor by using vector control. The vector control techniques allows a squirrel cage induction motor to be driven with high dynamic performance that is comparable to the characteristic of DC motor. So vector control, we are getting the characteristic of DC separately excited motor in induction motor. As we know that in induction motor, the stator current and rotor current are both are coupled so that there is no independent variables of armature current and field current. But in DC machine, there is always independent characteristics of the rotor current and the field current. So we can see here the DC separately excited motor which has armature and field winding. Both are separately excited by DC voltage. So both are separately excited from DC voltage. So here this is armature, this is field winding. So torque is proportional to phi into Ia, where phi is a field or flux and Ia is the armature. So for proportional constant we can say K phi Ia, or we can also write T is equal to K IF Ia. Now field current is there in direct axis component and armature current is quadrature axis component. So we can also write here T is equal to K ID into IQ, and both are independent. So this type of characteristics we can find out in induction motor by implement vector control method. So here we can see the ID, which is a field current axis, and IQ, both are perpendicular. So by vector control method we can find out the characteristic of DC separately excited motor in induction motor. Now we will see the main features of vector control induction motor drives. The first characteristic which we found in induction motor is high transient current capability. So whatever the switching operations, the current is not steady and is not stable. That capability can be find out by using this method. Second is increased speed range. Wide speed range can be possible by using vector control induction motor because the armature is not affected by the field current and lower inertia. So this is the block diagram of induction motor fed by inverter. This vector control will transform the direct axis stator current and quadrature axis stator current to the inverter, and that is fed to the induction motor. So that will decoupled by this method vector control features. This is the complete implementation part of vector control, where we can see here there is a two part which is isolated by the inverter unity gain. So that is this part, left hand side part is called the control part and right hand side part is a machine part. So control part, there is a control signal is coming from the input side or reference signal IDS, IQS. These are the reference control signal is coming from the any control technique by microprocessor or microcontroller or DSP. That will goes to the model to the direct axis and quadrature axis stator current component. So stator space of direct axis and quadrature axis current fed to the D direct axis and quadrature axis stator current to three-phase current. That is done by using two-phase to three-phase transformation, and the coming signal from that transformation IA, IB, IC are the three-phase current reference signal is fed to the inverter, which has unity gain, and that will be control signals will be reference from the output of this inverter unity gain is goes to three phase to two phase transformation model, and that is done by using Parkes transformation models. By this, that will convert into the again another block is to by giving reference control signals of cos theta and sin theta, that will convert to the DQ and DQ model in rotor frame. So synchronous rotator frame, we are getting a IDS and IQS. These are the direct axis current and quadrature axis current which are decoupled, and rotation is omega E. So this is called as transformation. This is part is also called as an inverse transformation. So this is all about the vector control method of induction motor. Thank you.